Hello, Coach Travis here with another calculus video. So we got a problem here. We want to graph the function log base 1/8 of x. And there's so we got this we're supposed to drag this red dot somewhere so that we wind up with the correct graph. So you might, and we can't actually move this point at the point 1, 0, we can't actually move. It's stuck. And you might say, oh my gosh, how am I going to draw the right graph if I can't move that point? But that's actually okay, because if you think about what the graph of a logarithm looks like, remember this, that if the base of the logarithm is greater than 1, then the logarithm has a positive, it's always increasing as we move to the right. And notice it always goes through the point 1, 0. And if the base of the logarithm is less than 1, then the graph is always decreasing, but it still always goes through that point 1, 0. So that's a really important point if you haven't noticed it about an important observation. If you haven't noticed it about logarithm graphs, the x-intercept of a logarithm graph is always at 1. So that's a good fact to remember. And okay, so back to the problem then. So our problem has the base being 1/8. So we know we're going to have to look like this. We're going to know you're going to have to look like the one on the right. So, all right, so I know that I need to drag this dot somewhere into the what's it called, the fourth quadrant here. But then where in the fourth quadrant am I going to put it? That's the question. All right, so I need to drag this red dot to an xy point that satisfies this equation right here, because the graph of this function is going to be the set of all xy points that satisfy this equation. So gosh, how am I going to find an xy point that is going to satisfy that equation? And so personally, to me, logarithms are kind of hard to deal with. So whenever I see a logarithm, what I like to do is I like to rewrite it as an exponential. So if I take this logarithm and I rewrite it as an exponential, then the x's and the y's trade places. That is that, like in this equation, the y is the output and the x is the input. But in this equation, the y is the input and the x is the output. So they trade places. That's what it means, because logarithms and exponential functions are inverses. So you should remember that a logarithm equation always corresponds to an exponential equation. And the only difference is the x and the y's kind of trade places. So all right, well, so now I could just try some numbers. So I could say, how about we make y equal to 1? So we could say y is equal to 1, and then x is equal to 1/8. So great. So we have a point. We know that the point 1/8, because that's x is 1/8, and y is 1, because the exponent is the y. That's a point on our graph. But it turns out that's not going to work, because there's a little wrinkle in this problem. I can't drag the dot to a point that doesn't have whole number coordinates. So I want to drag this point to x is equal to 1/8, but it won't let me. So if you read the fine print up here, it says you can only graph points that are whole numbers. So this, what I did here was completely correct. So we'll see that this point will be on the graph of our answer, but I can't actually use it to answer the question. So I'm going to have to try something else. So, all right, well, let's try something else then. Well, 1 didn't work, so why don't we try 2? So we got 1/8, and now we'll raise that to the second power, and but that's going to be 1/64. So that's another point, but as you can see, I'm kind of going the wrong way. I'm getting, if I make this exponent more and more positive, then this fraction is just getting worse and worse. So I think probably picking bigger and bigger positive numbers is not going to get me to where I want to be. So maybe those of you at home watching will think about what the right thing to do here is. Let's try putting in a negative number. So let's try making the exponent -1. Because, aha, if you have a fraction and you raise it to the -1 power, then you just get the reciprocal of the function. And so that means our point is going to be 8, -1. And again, remember that's because the exponent is always the y-coordinate, and the x, or the thing on the right-hand side, is always the x-coordinate. So the x is 8 and the y is -1. And I think I can probably drag my point to that. So I want my x to be 8 and I want my y to be -1. So that puts me at that point right there. And now we can probably see that these other 2 points, I bet, should be on that graph. Like, let's see what happens when x is when x is 1/8. So 1/8 is, oh man, I don't have my laser pointer is too big. When x is about 1/8, then yeah, it does look like the y-coordinate is about 1. And when x is, what about when x is 1/64? So 1/64 is really close to 0. And you can see from the graph that if I want to get the y-coordinate to be 2, the x-coordinate does have to be really close to 0. So sure enough, this looks like a pretty good graph. So I think that's how you do it. So again, what was the moral of this story? The moral of this story is whenever you have a logarithm equation, I think it's best to translate it into an exponential equation, because exponential equations are easier to deal with. And then once we had it in exponential form, then we were just guessing and checking. And we kept guessing and checking until we got a point that was actually that we could actually draw. And so never discount the power of guessing and checking either. Guessing and checking is actually one of the best problem-solving strategies that we have.